Now in question number 2, we are given this complex number and we have to find the modulus of it, and we have to show that its argument is minus pi by 3 in part A. So if we do that, the modulus of z will be root over its real component, which is 6, plus its imaginary component 6 root 3, both of them squared. In here we are basically using the Pythagorean theorem. So if we draw this, if we represent this number on the complex grid, this will have a real component of 6, so 6 on the real axis and minus 6 root 3 on the imaginary axis. So 6 root 3 over here, it will be somewhere over here. So it's the modulus wants the magnitude of this line, so the magnitude of this line over here. This value over here is 6 root 3, this value over here is 6. So this will also be a right angle triangle, so the magnitude of the hypotenuse over here will be root over 6 square plus 6 root 3 whole square. If we calculate this, we get a value of 12. Now the argument is the angle between this line. So this line we had over here, the angle between this line and the real axis, so this angle over here. For such cases, we'll always imagine a triangle like this with the angle over here with the real axis, and we'll get tan theta, so this angle, to be the imaginary component, the magnitude of the imaginary component divided by the magnitude of the real component. So theta would be tan inverse root 3 or pi by 3. Now we can have two different scenarios. We might have something like this with an angle of pi by 3. We can also have something like this with an angle of pi by 3. We want to differentiate between them. We can't just say its argument is pi by 3 and understand if it's going here or here if we don't bring a sign convention here. So we consider the anti-clockwise angle, this angle, to be positive and the clockwise angle to be negative. So if there was an angle like this, something like this, we'll at first imagine a triangle like this, find this angle. From that we can find this angle over here and hence find the whole angle for this. This will be a positive value. However, something like this, we'll do the opposite. So find this angle over here, theta. From that we can find this angle over here. This will be 90 minus theta, and this will be 90. So the argument for this will be 90 plus 90 minus theta and a negative in front of it since we are rotating it clockwise. So for this graph we are going clockwise on an angle of pi by 3, so the argument would be negative pi by 3. So we can just draw a sketch of this. Theta equals to tan inverse 6 root 3 by 6. So theta is pi by 3 and argument of z is minus pi by 3. Now in part B we have to use De Moivre's theorem to determine z to the power 4 in its simplest form. Now De Moivre's theorem states that if z is in the form of r cos theta plus I sin theta, z to the power n will be r to the power n times cos n theta plus I sin n theta. Here theta is the argument and r is the modulus of z. So we can write z in this form since we found the modulus and its argument in the previous part. So we can write z as 12 cos minus pi by 3 plus I sin minus pi by 3. So z to the power 4 would be 12 to the power 4, and on this we'll have cos minus 4 pi by 3 plus I sin minus 4 pi by 3. Now we need to write it in this form again. So this form, we wanted it in the they wanted it in the simplest form. This right here is the simplest form. To do that, we need to visualize what z to the power 4 is. So if we draw the graph, it has a clockwise rotation of minus 4 pi by 3 degree, which is 240 degrees. So somewhere over here. And it has a magnitude of 12 to the power 4. So this line has a magnitude of 12 to the power 4. If this is 4 pi by 3, the whole red stuff is 4 pi by 3. This whole angle is pi. So this remaining angle would be 4 pi by 3 minus pi. So this is pi by 3. Now to find the real component, so this is the real axis and imaginary axis. The real component, if you have done mechanics or physics, it would be breaking it into components. So on the near side, it will be 12 to the power 4 cos pi by 3. You use cosine with the line that it's making the angle with, and on the vertical component would be 12 to the power 4 sine pi by 3. If we calculate that, z to the power 4 would be 12 to the power 4 cos pi by 3 plus I. We'll have a negative over here since it's in the negative real axis, and a plus over here since it's in the positive imaginary axis. So I times 12 to the power 4 times sine pi by 3. From that we'll get z to the power 4 to be minus 10368 plus 10,368 root 3 I. Cos pi by 3 is half, Sine pi by 3 is root 3 by 2. 12 to the power 4 by 2 is 10,368. So this will be 10,368 root 3, since this is also half into root 3. Now moving on to part C, we have to determine the values of W such that W square is equal to Z. So we have W square equal to Z. So W would be plus or minus Z to the power half, or basically root over Z. We can use Demov's theorem again over here to find Z to the power half. So Z was 12 cos minus pi by 3 plus I sine minus pi by 3. So Z to the power half will be 12 to the power half times cos minus pi by 6 plus I sine minus pi by 6, multiplying the angles with half. If we visualize this, a clockwise rotation of pi by 6 and a magnitude of root over 12. So the real component would be root 12 cos pi by 6 and the imaginary component will be root 12 sine pi by 6. So Z to the power half would be root over 12 cos pi by 6 minus I, because it's in the negative imaginary axis. This is the positive imaginary axis on the top and this is the negative one on the bottom. So minus I root over 12 sine pi by 6. If we calculate this, we'll get Z to the power half to be 3 minus root 3I. So W will be plus or minus 3 minus root 3I. So W is either 3 minus root 3I or W is equal to minus 3 plus root 3I.